What if I told you there's a storm on Jupiter that has been raging continuously for over 350 years, and scientists still cannot fully explain why it hasn't died? Not slowing down, not fading, just spinning endlessly on a planet that has no land, no ocean floor, no friction to stop it. That single fact should terrify you and fascinate you at the exact same time. Here's what makes this even more unsettling. We've been watching Jupiter's great red spot for centuries, and instead of understanding it better, every new discovery makes the mystery deeper. In 2019, amateur astronomers noticed chunks tearing away from the edges of the great red spot. Scientists initially thought it was finally dying. Then it stabilized. The storm essentially healed itself. A storm healed itself on a planet 484 million miles away from us. Let's break down what's actually happening up there, because most people have no idea how extreme Jupiter truly is. Jupiter is not a planet like Earth. It has no solid surface. It's an enormous sphere of gas and liquid, mostly hydrogen and helium, with an atmosphere thousands of kilometers deep. When you look at those stunning banded clouds in photographs, you're looking at jet streams, rivers of wind moving in opposite directions at speeds reaching up to 640 kilometers per hour. These opposing jet streams are key. They act like invisible walls, locking storms into fixed latitude bands. On Earth, storms lose energy when they hit land or cold ocean water. On Jupiter, there is no such break. Storms just keep feeding. Now here's the controversial part that divides scientists right now. For decades, the leading theory was that Jupiter's storms are powered from above by sunlight heating the upper atmosphere. But Jupiter is 5 times farther from the Sun than Earth. Sunlight reaching Jupiter is 25 times weaker than what we receive. That's not nearly enough energy to sustain a storm for centuries. So where is the rayon fuel coming from? Data from NASA's Juno spacecraft, which has been orbiting Jupiter since 2016 and continues to send back revolutionary information, revealed something that shook planetary scientists. The storms on Jupiter are not shallow weather events. They go deep, terrifyingly deep. The Great Red Spot, which is about 1.3 times the diameter of Earth, extends downward at least 300 to 500 kilometers into Jupiter's atmosphere. That's not a surface storm. That's a storm with roots buried in the planet itself. This means Jupiter's internal heat is a primary driver. Jupiter actually radiates more heat from its interior than it receives from the Sun. The planet is still slowly contracting from its formation 4.5 billion years ago, and that gravitational compression generates heat from the inside out. That internal energy rises through the atmosphere and gets captured by these massive rotating systems, turning them into self-sustaining engines. Think of it like a car engine that never runs out of fuel because the fuel is the car itself. But wait, it gets more complicated. Scientists from the University of California, Berkeley published research showing that Jupiter's storms also cannibalize smaller storms around them. The Great Red Spot, rather than losing energy over time, actually absorbs smaller vortices that drift into it. It's been consuming storms for centuries. It's a predator storm, a storm that eats other storms to survive. Here's another layer that most science channels won't tell you about. The Great Red Spot has been shrinking. In the 1800s, it was estimated to be about 40,000 kilometers wide. Today, it measures approximately 13,000 kilometers. That's a dramatic reduction. Scientists expected it to disappear entirely within decades. That prediction was made multiple times and has been wrong every single time. Because as it shrinks, it also becomes taller and more intense. It's not dying. It's concentrating its power. A smaller, faster, more violent version of itself. Recent Juno mission flybys, including data analyzed as recently as 2023, used microwave radiometry to peer beneath Jupiter's cloud tops, confirming that the storm's roots interact with deeper atmospheric layers where the pressure is enormous, equivalent to thousands of Earth atmospheres. The chemistry down there involves compounds we barely understand, including ammonia ice, water droplets, and complex organic molecules forming in the dark under crushing pressure. And Jupiter isn't alone in this. Saturn has a hexagonal storm system at its north pole, a geometric hurricane that has maintained a perfect six-sided shape for decades. Uranus and Neptune carry storms that persist through their brutal conditions as well. Giant planets in our solar system seem to operate by rules completely different from anything we experience here on Earth. This is the pattern interrupt moment that changes how you see everything. We have been studying weather for thousands of years. We can predict Earth's hurricanes days in advance. We have supercomputers modeling atmospheric systems. And yet, a storm on another planet, observed with some of the most sophisticated spacecraft ever built, still has us genuinely puzzled. Jupiter is humbling us, and that humility is exactly what drives science forward. The most honest answer scientists have right now is that Jupiter's giant storms persist because of a perfect combination of internal heat, no solid surface to absorb energy, jet stream barriers trapping them in place, and a feeding mechanism that absorbs surrounding smaller storms. But combination of factors is scientific language for we're still working on it. If you found this as mind-bending as I did, follow this page right now, because we explore the universe's greatest unsolved mysteries every single week, and some of the upcoming topics will genuinely change the way you see reality. Now I want to ask you this. If a storm can survive for 350 years on a planet made of gas, what else out there in the universe is operating by rules we haven't even begun to imagine? Drop your answer in the comments below.